Hello Algebra 1 students. Welcome to your video on reviewing systems and linear inequalities. We're going to have some classical music in our background today, and I'm just going to jump right in and get started by talking about what's going to be on this test. Okay, for this test you must be able to identify the different outcomes possible when you solve a system of equations. We talked about this quite a bit. Remember that there are indeed 3 of those outcomes. 3 different outcomes, 3, and you should know what they are. Solve a system of equations by either graphing, substitution, or elimination. And we're also going to learn how to use your calculator to help you out with the graphing. So we should have done that in class by the time you get to this review. Write a system of equations for a word problem and solve. Graph or identify the graphs of individual or systems of linear inequalities. And then also write and graph linear inequalities for real-world application problems. So we're going to start with graphing systems. Okay, so page 405, here it is right here, page 405, 5, 7, and 9. And that's what I want you to go ahead and try. So go ahead and pause your video. Try these 3 problems. You are graphing. Remember that you do not have to have a piece of graph paper to graph, but please graph each of those 3. If you graph it on a graphing calculator, sketch the graph onto your homework paper or onto your iPad, however you're doing your homework. All right, I'm going to pause it, and I'm going to get these graphed up for you. And there you have it. Let's take a look at these 3 systems. Oh, forgot to label here. There we go. So this first one, you've got your 2 lines. They cross at -2, 6. And that's your solution for that system of equations. And that's the first type of solution you can have when you are solving a system. Here we go with no solution at all. They're parallel lines. I want to point out that I graphed this second equation, the one in blue, by using x and y intercepts. And I did that because 4.5 goes into 9 and 3 goes into 9. So it's easy to graph with y-intercepts. And I did the same thing here. With intercepts, x and y, not just y-intercepts. This last one, you'll notice, has infinitely many solutions because both lines happen to be the same line on that coordinate plane. All right, next one. Substitution, page 405, 12, 14, and 16. Ooh, sorry about that. That was the heat turning on in the classroom. Startled the daylights out of me, I'll tell you what. So we're going to pause this again. And I'm going to write these out. I want you to try it yourself. Remember how substitution works. You're going to be solving for one of the variables. So if you look, for example, in this first equation, the y is by itself. So we're going to be taking that y, and we're going to be plugging that 2x minus 1 into the other equation for y. So I'm going to pause it, write out the work, and then we'll go over it. Okay, have at it. And there we have it. Let's take a look at these. Number 12, solving by substitution, so plugging that first equation into the second. Now, even if you don't like substitution, I want you to remember that it's a valuable method. It makes this problem quite easy. You solve this equation, we end up with x equals 4. Go back and plug it in to the first equation because that's the easiest one to use to find y. And y is 7, and there's our solution for 7. Now, please remember that this is the most common type of system, is the one that comes out to an ordered pair solution. The most common type is the type where there is an ordered pair solution. The other 2 on this page, and in every situation thereafter in this video, are the other possibilities. Now remember that they are not as likely. They don't happen as often, but I need you to recognize what it looks like when they do happen. So for this one, to use substitution, I had to solve for this y. And in this situation, I probably would have used elimination better, but remember that's what the directions were with substitution. If you used elimination and you still got the same answer, then you're all set. But I used substitution, so I solved for this y, plugged it in, simplified the expression on the left side, and we end up with 24 equals 30 for the equation. Now we know that that's not true. When you get a statement that is not true, that's when you go ahead and realize that, this one doesn't have a solution. Infinitely many solutions for the third one. So the third one was already ready to go. Y equals x minus 7, so I plugged that in. Distribute and simplify. That 3x minus 3x cancels, and we get 21 equals 21, which is true, telling me this system has infinitely many solutions. And if I was to solve this second equation for y, it would look just like the first one. Awesome. Let's move on to elimination. Okay, elimination. So page 406, 19, 21, and 24. I want you to try them. Remember that elimination is where you're going to either add or subtract to eliminate a variable. None of these are readily set up for elimination, so you're going to have to manipulate each one. You're going to have to adjust, multiply the equations, think about it, use your notes, and I'm going to write it out and come right on back.
Violence.
And there we have it. Okay. So for number 19, you have no solution. It wasn't set up for elimination to begin with, but I noticed the 5x and the 1x, so I decided to eliminate the x, and I multiplied the top equation by -5 in order to do that. But once I did that, I noticed both x and y eliminate. We end up with 0 equals -60, no solution. Number 21 is also not set up for substitution, or graphing. I didn't mean to say that. I meant to say elimination, but it's not good for substitution, for graphing. And we talked about this in class a little bit, a couple classes. It's best if I pick a method that makes the best sense, and this is not a good candidate, either one of these, for graphing or for substitution. Well, that's actually not true. I could use the second one with graphing because the x and the y intercepts are easy to find. But the first one is not going to be convenient to graph. Anyway, I did notice that the y term has a positive and the x term has a negative, so I crisscrossed their coefficients. Once I did that, the y's eliminate, positive 12 and negative 12. We get 27x equals negative 297, and x equals negative 11. Plug it in, solve, y equals -7. Remember to write it as an ordered pair in the correct order, because sometimes they will give you multiple choice questions where the order, the other order, -7, 11, will be there as a choice. Number 24 is infinitely many solutions. It was not set up for elimination, but I adjusted it. I subtracted the 3x from each side to give me this equation. I multiplied the bottom one by 3, and then you'll notice it eliminates down to 0 equals 0. That's true. Infinitely many solutions. Remember, the most common outcome is still having one solution. I'm just showing you all three so that you get the hang of what it looks like when they come up. One application problem, and then you're going to be practicing some inequalities online. All right. Okay, so a word problem, and this one is one of those current problems we talked a little bit about in class. In this situation, it's a kayaker. Okay. It looks like I meant to type the page number and then totally neglected to. So let me, I'll give you that when I'm, in just a second. Let me find that for you. Okay, sorry about that. For those of you using the textbook, it's page 387, number 12. And all of these will be listed in the post for the homework as well, to help you prepare for actually watching the video, doing the problems ahead of time, preferably. Anyway, a kayaker paddles upstream from camp to photograph a waterfall, and then he returns. The kayaker's speed while traveling upstream and downstream is shown below. What is the kayaker's speed in still water, and what is the speed of the current? Define some variables, write some equations, and solve me the system. I'm going to do the same thing, so I'll pause it and write it out, and then we'll take a look at it together. And there we have it. We have our answer. So let's talk about how we did this. So it started with x is the speed of the boat in the still water, so without the current pulling or pushing it, and y is the speed of the current. When you're going with the current, that's 7 miles per hour, and you know that because it's the faster speed. That's x plus y, the boat plus the current pushing the boat, and that's 7. And then the other one you know is the smaller one, so that's x minus y, and you get 4 for the boat without the current, with the current holding it back. When you use elimination to solve this, the y's cancel, you get 2x. Common mistake is to accidentally just put x here, so make sure you remember that's 2x equals 11. Divide by 2, and x equals 5.5. Plug in the 5.5 and solve, and y equals 1.5. So, the current, sorry, I hit the wrong tool. Okay. The current is moving at 1.5 miles per hour, and the boat by itself can travel at 5.5 miles per hour. Not a hard problem to figure out, not at all. Okay, let's take a look at what I have for you to practice with systems of, with inequalities. Okay, a couple of different websites here. The Khan Academy links, and again, I'm going to include these at the in the video post. The Khan Academy links are wonderful interactive ones that we will probably have seen in class by the time you get to this. And then we have some linear inequalities word problems on this IXL math link. There is an IXL math app. I do not think that they are totally in sync, though, the two, the website and the app. So I'm not sure that you're going to be able to find that on there. But if you do, definitely let me know. All right, guys, thanks for watching the video. I'll see you in class.